Mr. Akilur Rahman from Hitachi Energy. He is presently positioned as CTO of Hitachi Energy India, leading technology, digitalization, and innovation in the market. He has more than 32 years of experience in research, R&D, technology management, engineering, business, and product development in power and automation technologies. Presently, he is leading the core automation and digital technologies for power, energy, and asset performance management in utilities, industries, infrastructure, and transport sectors. Mr. Akilur will present a talk on how digital substation will drive the performance and dependability of the power. So let's welcome Mr. Akilur.
So as we had very interesting discussion, the panel discussion. So I would like to just refresh, some of the thoughts we already shared. The panelists also shared. Looking at why we need substation and digital substation, what's the importance in the future, present as well as future context. We know that we have the carbon neutral goal in the country level for the utilities, industries, country, 2070, and then, industries, they have announced 2050. Some of the industries, they also have announced 2035 as carbon neutral target. And we also have the actions for that already have started from government policy point of view, as well as utilities and also the industry. That's why how you are seeing that more and more renewables are also coming into the grid. And then also we have this 2030, target for renewable, 500 gigawatts of renewable. And then, so what's happening is more and more renewable, as one of the co-panelists also talked about, that we are going to lose the moment inertia in the system. So how do you manage the demand and supply gap in the power when we have the intermittency in the renewable? So with that, the substation is becoming very, very important in terms of, because that's the bridge between the generation and the transmission, or the transmission and distribution. And conventionally, it was like very fixed kind of substation because you have the generation fixed. So, so you build the substation once and then it runs for 10 years, 15 years. But now, and also in future, the substations, they have to be very, very modular. You can start with a substation with a capacity of maybe 1000 megawatt, 500 megawatt, but maybe every year you have to add, 500 megawatt. I mean, that is how, if you look at our renewable, power goal, 500 gigawatts, it will happen. Whether it is utilities, industry, they will start with some amount of renewable power, like, Kutch, Leh, Ladakh, where it will start with 1 gigawatt, 2 gigawatt of solar power, wind power, combined maybe in some cases. But every year there will be addition. So the substation has to be, whether it's a collecting substation or pooling substation, they have to be also modular, and you have to add the modules in terms of bays, and also at the same time ensure that the reliability of the substation is also maintained, because you need the resiliency of the power system. And this substation will not be only just substation. As I said earlier, it can be also co-locating storage, for example, utility scale storage, battery energy storage, or even it is connected to a pumped hydro storage. So in that case, not just the primary equipment where it has to be modular, adding a transformer and also adding the bay, the switch gear, whether it is gas insulated switch gear, air insulated, or even hybrid, which is gas and air together. They have to be modular, and as you add more and more renewable energy, which is going to be faster. You have the solar panel, you have the area like Kutch, Leh, Ladakh, and also Rajasthan, where the land is available. It's only a matter of you put the solar panel and you inverter, and then you connect to the substation. So that will happen fast. So then the substation also has to be accordingly scalable faster. Otherwise, we'll have the power source ready, but we don't have substation ready to evacuate the power. Similarly, on the receiving side, if you look at the substation which is delivering power to the discoms, where you also have the electric vehicle charging infrastructure there, a lot of new electrification loads will be coming. So with scalability in the primary technology, it is also important that how the automation of the substation, they are also scalable. There actually the digital substation would help, because first of all you need to have less space. Sometimes within a confined space you have to scale up the substation, and second thing is you have to have faster engineering, installation and commissioning of the substation automation equipment, the panels, the wiring. So that is how with the substation, digital substation, you don't have to have a huge amount of copper cable running. That will take more time. And you are doing that in a live substation, right? So with digital substation, fiber optic, then you can do it very fast. You can also have like digital substation, your panel, the number of panels, junction boxes and all, they become almost half. So you reduce the space. And your installation commissioning time is also less. But having done that, then you also immediately are able to hook into asset performance management system with the sensors, with the inbuilt sensor, or maybe with the auxiliaries you connect, and then you start getting the information about the substation, about its equipment, or the transformer, switch gear, disconnector, if it is storage, or you have also microgrid connected for the auxiliary power. So all these, they have to be done fast, and also the communication has to happen very fast, because then you have to make the substation running with the higher power immediately. So that's why it's important to have a digital substation which can be, along with the primary side modularity on the automation communication side, also it can be scaled up very fast. And we can also have all these asset performance management. We can also have the digital twin, which can be created for the substation, for the base substation. And as you go adding more and more equipment, and also more and more automation, the relays, the control panels, as you add, so the digital twin also is getting formed for the current, the latest substation. So that helps in, again, first of all, getting the real-time data about the substation, also training the workforce. For example, the new generation of workforce will be coming into the substation, and then now compared to earlier, I mean, the engineers in substation, they have to be master of different disciplines, not only electrical engineering but also communication, computer, IT. So they have to deal with that. So how they can learn these things faster, and in a live substation, how it is scaling up. So there the digital twin will help them, even before they go to the substation. They can have the training in a virtual environment, augmented reality, digital twin environment, to learn about the substation, how it has been built, and how it is going to be also built in future, with even the 4D kind of concept, where the time based how the substation is going to grow in next 2 to 3 years. So all those things can be also done. The training can be provided to the new workforce, and also the the old workforce, which is sort of retiring. The transfer of knowledge can happen to the new workforce, and the digital twin can keep all these information in the system, so that you don't lose any competency, knowledge, experience from the past. Then as we go further, so there will be also new type of storage system. I mean, we talked about battery energy storage, but there will be also, let's say, the green hydrogen production, which can be also co-located near the substation, or it will be connected to that. So green hydrogen production, and then that hydrogen can be used for the fuel cell, let's say hydrogen fuel cell based storage, which can again feed back the power to the system wherever there is shortfall of power or peak shaving you want to achieve. And then same fuel cell also can be used for the electric mobility, the EV, the electric vehicles, for that. So a substation, and in and around substation, the space, they can be used for multi-purpose like this: evacuation, storage, battery energy storage, or hydrogen electrolyzer based production, green hydrogen production, and then fuel cell. And also when you talk about the delivery substation, power delivery substation, there again, it can be also augmented with the EV charging fleet, electric vehicle charging, the buses, where it can be also fast charging, not just the normal charging, but fast charging of the fleets, vehicles, ultra fast charging, and also flash charging. We as Hitachi Energy, we have the technology where 20-second the bus can be top up charged. So all those different technologies and also scaling up of the system can be achieved if we design the substation well. If it is a new substation, or if it is an old substation, how we can redesign, create, the as-is analysis of the substation, the design, and then see digitally how we can simulate the scaling up, augmentation of the substation, so that all these new sources of energy, new type of loads, storage, they can be also augmented in the substation. And what's also very important here is that the substation will also be run, owned or operated in a different way. Conventionally, one utility was doing, but in future probably it will be somebody is owning the substation, but the operation is done by another agency, which is again performance based. There can be also model like energy as a service, or we are also talking when it is coming to the charging infrastructure, substation charging as a service. So these kind of business model, they also need the very real-time quantifiable data from the system. So that is how you can work on the economics of it. How much you charge whenever you have a renewable substation, which is evacuating power, and but it also has a storage. So how much to evacuate, how much to store, will also depend on what is the price the owner operator will get. If they are getting, there is abundance of power in the network grid, the price they will get is less, so they can store it, so they can sell it whenever there is a shortfall of energy, or during the night time, the renewable energy is not there, so need for renewable energy will be there. So substation would be kind of a host for all these different type of business models, energy as a service, and charging as a service, and also the performance based operation of the equipment, the sensors, what we are talking about, the IoT, possibly the way the aircraft industry today, the sensors, the monitoring system, they are owned by the OEMs, because they can accordingly provide reliable services for upkeepment of the equipment assets, and ensuring that they are serviced, and before they malfunction or fail, in their service. So there again, this predictive maintenance using AI ML applications concept, they can be used to predict and ensure that they are operating well. There is no surprise, in terms of, because in renewable case, if you have the upstream line tripping or downstream line tripping, then you are basically, it's a waste of energy. I mean, you are not able to evacuate the energy, but whereas the solar energy is there, so it's a pure loss. So how do you ensure that having all the equipment system running in a more predictive way and efficient way? So to sum up, the substation is going to be like a hub, the bridge between all these different sources of energy, different consumption of energy, different business model technologies, whether we talk about the primary technology, the digital technology, digital twin, asset performance management. So this has to be very, very modular, and it also needs collaboration among all different types of, whether it is OEM of primary equipment or OEM of the automation, the substation automation, products, systems, SCADA, EMS, and also the digital, the sensor, service providers, and also, let's say, the thermal scanning of the substation, thermal imaging, how you can do it. Also putting the video based applications where you can also image and video processing based information, which can be analyzed, and then you can have any malfunction, any vulnerability you can check. And also from cyber security point of view, that maybe specific agencies who will take care of the cyber security of the substation. So for them also, it's important, to have all this communication in place, and also remote monitoring. It should be there also in many cases where the substations will be in remote areas. For example, whether it is Rajasthan deserts, or maybe Kutch in Gujarat, or in Leh Ladakh, you can't have a big workforce there. So you have to manage with less workforce, but mostly you can do with remote monitoring. You can monitor the system. You can also do some kind of operation remotely, so that the system is running reliably, efficiently, with flexibility. And then the communication is very important. The deterministic communication, reliable communication is very important. And also with that, the digital substation plays a very, very important role to manage all these different complexities, technologies, and also performance requirements. And finally, I would say that it's not just the individual equipment or fleet of equipment what we are going to monitor or have the predictability there, but also the entire system. So that's why reliability-based maintenance will be very important for a substation, which digital substation can enable it. Reliability-based maintenance, in the sense, not only just looking at a few assets in the substation, but also the entire substation, the base, and also the different switching schemes. They are all monitored in real time. And the importance of the equipment, the criticality of the equipment inside the substation, they also can be defined, so that you know that in this substation, this bay is very, very critical, or in this bay, this particular equipment or this particular transformer or circuit breaker is very important, or maybe it is very vulnerable, so that you can give proper attention to those critical equipment, because if they malfunction or fail, then the entire substation or the bay can also be tripped, and then your power evacuation will be affected. So reliability centered maintenance, predictability, and of course the prescriptive maintenance with asset performance management, digital twin. So all those things can really make it working. And so that's why we need to also have, and as I said, it's a collaborative effort by all the different OEMs, service providers, and owners, operators to work together. And that would be not only the technology hub, but also I think it's like a stakeholder hub substation would be to ensure that the system is reliable and working, and making it a smart grid.